All right, learning targets. By the end of class, you'll be able to factor a trinomial into two binomials and be able to write equivalent expressions. It is very important that you can understand this as being equal or the same as something else. So we're just trying to write it in a slightly different way. Now, as I've said, we've already done two types of factoring. We've factored by GCF, we've reversed the distributive property, and we've factored the difference of perfect squares, where we multiply two binomials that were conjugate pairs, meaning they were almost identical except for their sign was different. So today we reverse the process of multiplying binomials so we can relate it to factoring trinomials, because typically you get a trinomial when you multiply two binomials. And if you're tired of me saying polynomial, monomial, binomial, trinomial, I apologize. It's just the language of the unit and something that we got to get used to. So here we go with two binomials. They're binomials because they have two pieces. And so, like we've done before, we're going to take those first two pieces and multiply it by the second binomial, the x plus 7. So we create a distribution problem of x times x plus 7. And then we do it again for the -2, and we do that as -2 times x plus 7. And if this looks familiar, yes, this is nothing new. I'm setting the stage for how we're going to do this whole process backwards. So a real quick refresher on how we multiplied binomials. Believe this was maybe like lesson 28, something in that range there. So I distribute the x, and remember this makes an x squared. So x times x makes 2x's, or x to the second power, and x times 7 makes 7x. We do it all again for the -2. We distribute it to both terms, -2x and a -2 times a +7. How about a -14? So we said trinomial, right? I thought this was going to be three pieces. Well, remember we combine like terms. So right here we have the same two terms for x squared plus 5x minus 14. And in fact, a trinomial answer. Let me make that a little bit better, 5. Okay? So now we know how we come up with one of these. We have to do the task of putting it back. We want to make a trinomial look like two binomials again. And the easiest thing to do is to break up the x squared, right? Because x squared means two x's, and so that means there was an x in the first part and an x in the second part, right? No different than our last one, where, let me get my highlighter out. We did the x here times the x here, and it made x squared. So the two x's got multiplied together, and that's where we came up with the x squared. Now, the other part isn't so simple. I'm not going to say hard, it's just not so simple. The other part is a combination of adding and multiplying. So when it's in descending order, we added to this term and we multiply to this term. And let me show you where that came from in our most recent example. So the one that we had here, remember, let me choose a different color. We got the 5x by adding, these two terms together, and that gave us our middle term. So that came to us from adding. So that's where that comes from. And the last term, the -14, I'm going to stick right on this and show you that it came from multiplying the -2 times the 7. So in trying to undo this process and trying to figure out how we got here, we have to understand that we added to get the middle term and multiplied to get the last term. And those are important clues to help us figure out how this all goes back together. So if I multiply to 10, I can make a quick factor list of 10. So 1 times 10, 2 times 5, 5 times 2, but I'm repeating myself. No 3, no 4, because they don't go nicely into 10. Now, I need to try to figure out how to add to 7 and multiply to 10. And I've been doing this for a while now, and it seems to really help students figure out what happens. So put an X on your paper and put a plus sign in the top and a multiplication sign in the bottom. And then in the top, we have the addition sign. Put the plus 7 here, okay? Because we know we have to add to 7. And in the bottom, put the plus 10 because that is where that's the number that we're trying to multiply to. Now, out of our factor list, we know that both of those multiply to 10, but only one pair will actually add to 7. And so if you look at 1 and 10, that's not going to do it because 1 plus 10 makes 11. But 2 and 5, those numbers are going to do both things. It's going to add to 7 and multiply to 10. So a positive 2 and a positive 5 must be the two numbers in this binomial. Okay? So there's your first one. Hopefully that didn't give you too much heartburn or indigestion or feelings of, oh my gosh, I can't do this. Give me the chance to go over this a couple more times and you'll be a pro in just a matter of moments here. So again, let's look at the next one and think about what we're trying to create. We're trying to create two binomials. We're trying to put this back into binomial form. I need to factor 6 because the last number is what we multiply to. That's how we came up with that. Now 6, there's only a few ways to multiply to 6. 1 times 6, 2 times 3, 3 times 2 is just the repetition of the one before it, so we're not going to use that. Now, when I think about what I have to then do, I make the x because I need to add to 7 and multiply to positive 6. Only one pair of numbers successfully does both things. It can't just do one, it's got to do both. And that's going to be the 1 with the 6 because 2 and 3 will not add to 7. So I put a 1 here and a 6 here, and does it work? 1 plus 6 is 7. 1 times 6 is 6. So a lot of integer rules go into this, and of course multiplication facts. Now x squared, same thing, breaks up into x with x. And we write this as both positive because it's both positive numbers, positive 1, positive 6. And that's it. You've just have rewritten a trinomial as two binomials. So again, we're trying to rewrite the following trinomials as equivalent binomials. So we know that these are going to be equal. They just look different. And so whatever the first letter is, it doesn't matter if it's B, X, Y, Z. So we just break that up into two pieces. B there and B there. When this is just B to the second power with a 1 here, let me tell you, these are a lot easier. We're not going to do the other ones until after spring break anyways. So don't be worried about that. Next up, we're going to multiply to the last number. That's why descending order is important, because if it doesn't have the variable, it's the last number, and that's what we multiplied by. So factors of 8. Hopefully you can do these on your own. If not, just go in order, 1, then 2, and divide them by 8. So 8 divided by 1 is 8, 8 divided by 2 is 4, 8 divided by 3 doesn't work, 8 divided by 4 is 2, but I'm kind of repeating myself here. So once you do that, we're thinking about how we can, and I'm going to do the x just to kind of help our thought process here, add and multiply to a number. So think to yourself, what number are we trying to add to? Remember, it's the number in the middle. And when it's in descending order, -9, but we're multiplying to a positive 8. And you're like, how in the world is that going to happen? It seems like there's no possibility of that. Well, 2 and 4 are certainly not going to happen. So don't use that. It is a 1 with an 8. But now here's where integer rules are so important to you because they're different for adding than they are for multiplying. If I want to add and get a -9, well, both of these are going to have to be negative. -1 plus -8 makes -9. Boom, boom, boom. But if I'm multiplying two negatives, a negative times a negative, aha, in fact, I get a positive 8. So -1 and -9 would be the two numbers that do both things. All right. We take another look at that. Negative for one of our signs. So clearly, multiplying to this number adding to this number, and that's an important idea to remember. 20 could have a few more factors than we've seen before, so let's try it out. 1 times 20, 2 times 10, 3 no, 4 times 5, 5 times 4, that's enough. As soon as I start repeating myself, I can stop. We're trying to create two binomials. We have b squared, so let's break that up into two b's. And now think about the pair of numbers that would get us to -9 when we add. Do you have to use the x? No. But do I use it to teach you good habits? Certainly. This will definitely get you into the right mindset. So we need to add to -9, multiply to +20. Looking at our list, 1 and 20, not going to get us to -9. 2 and 10 can get us to 8 and 12, but not -9. So it's going to have to be the 4 with the 5. Now, once again, signs are always important in this class. If we have a negative when we add them, and we're using 4 and 5, we're going to have to make them both negative. So you got -4 plus -5 making -9, and a negative times a negative making a positive. So -4 minus 5. And there you have it. You've just written an equivalent expression. We got 4 down, we got 2 to go. We still think about trying to get this into two binomials. And by way of adding to this number, multiplying to this number. So factors of 18 would be a good way to start. That would generate a list of 1 and 18, 2 times 9, 3 times 6, 4 no, 5 no, 6 and 3, and guess what? We're just repeating ourselves at that point. Go ahead, put down the x. Think about what you have to add to and what you have to multiply to. So we're going to add to +3. We're going to multiply to -18. Can you think about the two numbers that will do this successfully out of those pairs that we have to choose from? Hopefully you're not thinking 1 and 18, nor 2 and 9, but 3 with 6. Now, how do you get it to be +3 when you add it, but -18 when you multiply it? Clearly, if it's a negative when you multiply, the signs have to be different. And when the sum, the answer to the addition problem, is positive, the bigger number takes that sign. So the bigger number is positive, the smaller number is negative. And there it works. A -3 plus 6 would actually subtract to make +3, and a -3 times +6 would make a -18. We've got y squared this time, so break it up into y with y, and then -3 plus 6. And I get this question a lot every year. Can you write this as y plus 6, y minus 3? Yes. So if you want to change the order of the numbers and where you put them, that's okay. Just make sure that it's variable, then number, variable, then number. Before we get into breakout rooms, I'd like you to try this. So we want to break this up into two binomials. Find the ones that add to -3, multiply to -10, and the only list of factors that will do that are 2 and 5 with one +2 and one -5.